Alright, grade 11, we're starting grade 11 maths with the number systems. First lesson, we're going to look at the number systems that you've been doing for forever. You started off with this in grade 8. Somewhere when you were this small, somebody said to you, come tell Uncle Charles, how can you count? Start counting for him. And you say 1, 2, 3, 4, 5, and they say, yay, everyone, fantastic. You started off counting with 1, 2, 3, 4, 5, which we call the natural numbers. So on the natural numbers, we have numbers from 1, 2, 3, 4, etc. And we can go dot, dot, dot and put it in the number method set notation. Then we saw, but listen, we need something else. There's something short here. We also need a 0. So if we add a 0 to that, we get to what we call the whole numbers. Only thing added to the natural numbers is 0, 0. And goes on until infinity. Then they saw, wait a little bit, if I do subtraction, say for instance of two whole numbers, 4 minus 7. Your answer is a negative and I don't have them. I need the negative numbers. So if I add to that all the negative numbers, dot, 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 minus 2, minus 1, 0, 1, 2, etc. until infinity, we call that the integers, which is made with a Z, with that extra little line there. And there's a few variations. You'll see them in textbooks and question papers. Sometimes they make them a squiggly Z. Most of the time it's with that extra line in there. Then we call that the integers. So what it means is that the integers enfolds the rest of them. So inside of the integers are all the whole numbers, are all the natural numbers. Then we also saw, but listen, I also need something else here, just except for the whole numbers and the integers. What else do I need?
Rational and irrational.
What is irrational and irrational numbers? What do you need?
Recurring integers.
You need
Fractions and
fractions. You need fractions. So in between them, now tell me how many fractions are in between 3 and 5, 3 and 4? How many fractions between the number 3 and 4? A lot. A lot. Infinitely many. Because if you each tell me one, then there's still infinitely many between the ones that you're going to give me. So we're needing fractions. Now those are the fractions, but the fractions are broken up into two. Either you've got decimal fractions that are recurring and ending, or you've got decimal fractions that are non-ending and non-recurring. But I'm getting to the essence of it. What you really, really need to know is what I just said. Rational are decimals that are ending and recurring, and irrational are decimals that are non-ending and non-recurring. Let's just write it first. So rational numbers, if I want to look at rational numbers as a set form, let's be very mathematical about this. So if the maths is that it's fractions, the fractions are, if I write it like that, I'm saying it's a set of fractions. You read it with me in English. Set of fractions, so that, and in maths it's very specific to have a forward slash, backslash. That means so that. Backslash means without. Just for interesting sake, nobody's going to ask you that, but it's for interesting sake. So it's the set of fractions so that what must happen? The top must be an integer. How will I say the top must be an integer? The A must be an element of Z. So the numerator must be an integer, and as well as the denominator must be an integer. So both of them, something like 5 over 7 or whatever. Very important. This bottom thing cannot be not negative.
The square root.
What can you not divide by? Why? Since forever you've been taught that you cannot divide by a 0. So any fraction that can be written as something over something can never be 0 at the bottom. That's in essence what you have to know. That in essence is the rational numbers. But I'm saying let's make it more simple. We're just going to say it is ending or recurring, not both, one of the two, decimal fractions. So if you take any number like a half, 1 over 2, sounds like, right? But if you make a decimal with your SD on your calculator, it's going to be 0,5. Do you see it being ending and recurring? 0,5 or 0,135 ending. So it's rational. Are you with me? But then, what will the irrational numbers be? I said it. Can you remember? Will be non-ending and non-recurring. Also, decimal fractions. So if you need to discern whether a number that I give you is a rational or irrational number, just go to your calculator and put SD. If it doesn't end and doesn't recur, it's irrational. If it does end or recurs, it is rational. That's the basis of it. So let's go back to our picture, saying what envelops what. So on this, we've already got all the integers. We're just adding the rational numbers, rational normal fractions that are ending. And they are in between all of these numbers. Okay, exactly in between of them will be the rational numbers, Q with a little line in there. But the irrational numbers doesn't fit here at all. It can't be outside here. It's on its own. Anywhere you like to sketch that for yourself is fine, but that would be your irrational numbers, which are, for example, the most common, well-known irrational number that you know is pi. Excellent. For example, pi. That's not the only one. There are lots of them that don't end and don't recur. If you go to your calculator and you put the pi in there, it's going to stay pi until you say SD. But then you'll say that it's 3,1429 what, and it only stops because your calculator stops. It doesn't have a window for further. Some people know pi up to 20 and 30, I don't know how many of them, just for being cute, but it's not necessary. But it doesn't end and it doesn't recur. Can you see that I can't sketch them inside of each other? This whole method is, inside of the rationals are all of the integers. Inside of them are all of the whole numbers. Inside of them are all of the natural numbers. But the irrational ones has got nothing to do with the rational ones. They've got to be separate. But together they make up the real number system. So the real number system is basically when I take the rational and the irrational and I unite them. Can you remember that from probability last year? We unite, just put them together. All of the irrationals and all of the rationals put together adds up to be the real numbers. That's it. There's nothing floating around out here. But sometimes things happen that shouldn't happen. Like, for instance, if you divide by 0, we've said that already, that answer is what? Divide by 0?
Non-real.
Not non-real. Undefined. It is an error. Undefined. You were taught very well in grade 8 and 9 and even in grade 10 that there's a difference between undefined and non-real. Undefined does not exist. You cannot divide by 0. Okay, there are undefined things. But non-real is something that does exist, just not in our real number system. So the non-real number system, or the imaginary number system, or the complex number system is something that you'll only hear about when you go off to school and still study maths. It's very abstract. Right, there are such things. Once you get your new calculator that I want you to get, you'll see sometimes you'll get an answer like 3 plus I. What do you think the I stands for? Okay. So your new calculator can handle that, but you're not going to work with it anyway. But that is what the imaginary number system. But there are such number systems, the imaginary number system. We just don't use them. So for a number like -7 in a square root, your answer would be not real. But for an answer like 6 divided by 0, your answer would be undefined. All right, and that is the number system in a nutshell. Right, before we get into our first chapter, which is going to be exponents, we've said it already, but I'd like you to keep in mind, every time now and again I'm going to ask you, listen, some things in maths shouldn't happen and there's a problem with it. I call it the 3 red lights, it's just what I call it, you'll not find it anywhere else. I'm talking about 3 red lights, which we've discussed. You can never divide by 0, because that is undefined, because you can do it. How can I divide 0 into something? How many times does 0 go into something? Nothingness into something, not 0. It can't work. Okay? The next thing we've also discussed is whenever you've got a negative inside of an even root, because it doesn't only have to be a square root, it can be a 4th root, 46th root, whatever, even root, the answer will be non-real, which does exist, just not in our number system. Are you with me? Can't have the 2 answers swapped around. And then the last thing that I haven't seen in ages that they've asked it can be a 1-mark question in a matric paper. That I'll ask you something like that, I'll get to it just now. What is 0 to the power of 0? Now we all know the exponent law says if you have anything to the power of 0, the answer is 1. But that's not quite right. There's an exclusion. That A cannot be 0. If you put 0 to the power of 0 in your calculator, it'll give you an error. That's the same thing as with division by 0. You cannot put 0 to the power of 0. Times 0 with itself was nothing times. It doesn't make sense either. Okay, so that will also be undefined. And these 3 rules, most of the times it's these that are in play in some questions. For a 1 mark in a matric paper, they're going to ask you something about being real or non-real, being defined or undefined. For example, okay, but I just want to finish the exponent law. So I'm saying the law is only equal to 1, anything to the power of 0 is equal to 1, if that A is not 0. So that's an exclusion to the rule that you haven't really been stressed into in grade 8, 9, 10 because it wasn't necessary. So if I ask you a question like this, for 1 mark, maybe 2 marks, tell me please, for which values of x will this thing, 0 to the power x plus 2, be undefined? You'll not know that unless I've just taught it to you. So it has to be 0 to the power of, which will make it undefined. So I'm asking, when will it be undefined? If that x is negative 2. Oh, fantastic. And if you just say negative 2, that's fine. Or if you want to say, in other words, if x plus 2 is equal to 0, and then only work it out like a linear equation, and say x is negative 2, that's fine. But if you just say negative 2, perfect. You see where you got this idea in? Yes. For a 1 mark question. Also, something different that's over here, I'm asking you for which values of x, because there might have been more than 1, but there isn't. So it could be just 1 or more than 1. So the questions usually ask that. You saw that in graphs as well, for which value or values will this be bigger or smaller, whatever. So let's look at example 2. Same thing. For which value or values of x will this thing be defined? Meaning it has to work. The only thing that's wrong with it, or that could be a problem, the 3 red lights, is it's got nothing to do with roots. It's not 0 to the 0. It's definitely got something to do with maybe possibly dividing by 0. Are you seeing what you should be looking at for being defined or undefined? So the problem here would be if I divide it by 0. So when will it be defined? When will it work? If that x is not the x, positive 3. The whole denominator mustn't be 0. But x then has to be 3 to be undefined. So for x minus 3 has to not be equal to, do you see the difference in the question? When will it be undefined? If it is what it shouldn't be, when will it be undefined? Okay, so this one asks, when will it be defined? That would be if the bottom is not 0. So that would be x is not equal to 3. Then it will be defined. So if the question said undefined, you would say for x equal to 3. What about the x squared plus 2 at the top? Nothing. It's got nothing to do with the thing being defined or undefined. And those are the three red lights.